Everyone, welcome back. So let's do another problem, and in this one we're going to be calculating the heat capacity for different metals. Well, in this case, let's do bronze because there's more or less the same process for each of them. Okay, so as a note, heat capacity is Cp. That is not the same thing as specific heat, which is also Cp. This guy is lowercase, this guy is uppercase. And they are totally related. And I'm going to do my best to write a big C for everything we're doing here when it's just heat capacity instead of just for specific heat. Now, first off, how are these two related? Well, heat capacity is per mole. Specific heat is per mass. So that's the conversion you have to do between the two of them. So what we're going to be doing is we're going to say, okay, heat capacity, you are going to be equal to the specific heat, lowercase there, times, divided by the atomic weight. There we go. There's also some conversions we'll have to do in here to make it nice, but that's the basis. So these are all from tables. You can just look them up. Usually this is from the tables or the periodic table. So it's not too hard to calculate this. So what I want to do in this case is to give you a little bit of a harder problem. We're going to do this for brass. Now brass is an alloy, and because it's an alloy, I don't have its atomic weight right off the bat because it can have different compositions. So we're going to do a 70% copper, 30% zinc brass alloy. So you might be wondering to yourself, well, what is A in this case? Well, A in this case is going to be the average atomic weight for this brass alloy. Okay, that is what we're going to do here. Okay, let's see. So as a note, these 70%, that is weight percent. So just giving you that clue there, it's not atomic percent, it's weight percent. Now how do we get the average? Well, the average atomic weight is equal to 100% all over my weight percent for 1. So I'll do, let's see, I'll just call that weight percent copper over the atomic mass of copper plus the weight percent for zinc over the atomic weight of zinc. Perfection. This will give me my average atomic weight. So then, what is my values for all this? Well, let's just plug it in. So I'm going to have 100 divided by 70 over 63.55 plus 30 over 65.41. And as a note, these things in the bottom, they're grams per mole. That comes out to be 64.09 grams per mole. Okay, so now I can go ahead and plug this back into my original equation, which I'm going to do right now. So my heat capacity will be equal to my specific heat divided by the atomic weight. Specific weight for brass is, let's see here, yes, 375 joules per kilogram Kelvin. I'm dividing that by the mass, which is 64.09 grams per mole. One issue there is you see there's kilograms on the top and grams on the bottom. I need to cancel those out. So I'm going to have to convert this guy on the bottom to kilograms. And so there is 1,000 grams per kilogram. And so with that, kilograms cancels, grams cancels, and I'm left with the heat capacity, which comes out to be 24 joules per mole Kelvin. That is it. As a note, for various metals, the heat capacities are actually very, very similar. Like if I were to do it for let's see, aluminum is like 24.3. It's always somewhere around 24, for a lot of metals at least. So if you try it and you see similar numbers for different problems, don't be scared of that. That's to be expected. So this is it. We calculated heat capacity. Thanks for watching. I hope it helps you. I'll see you all next time. Bye-bye.